Welcome to topic number 9, measure of relative position. So in this video, I want to talk a little bit about what is the measurement of relative position. Basically, it reflects back to what we talked about before, what lies in the middle. It's the central tendencies, okay? So this thing called quartiles, we know core is divided into 4, okay? So quartiles is divide the entire data set into 4 equal parts, where each quartile is 25% of the data. Okay, so this thing called the 5-number summary is basically divide your data into 4 equal parts, where you have a minimum value, maximum value. The M here is the median. Okay, Q1 is called quartile 1 and Q3 is called quartile 3. So these are the 5 numbers that help us divide our entire data into 4 equal parts. So we talked about median before, what lies in the middle, right, of your data set. Okay, so now once I got the middle part, so if this is my entire data set, once I got my middle, then I can divide rest of it, the first half. If I divide that half again, that's what the Q1 is. That number representing that's the first half of the data, the median of the first half of data. Q3 is the second half of the data divided by 2, make it into 4 equal parts. Okay, so that's what Q3 is. This number representing that's the number of the third quartile. And of course, the minimum and the maximum is at the very end. Okay, so how do I find quartiles? Number one, we're gonna arrange the data in ascending order. So I'm gonna just kind of rewrite this in an ascending order. So 61, 69, 72, 77, 78, 80, 82, 88, 91, and 95. Okay, arrange my data ascending order from small to large. Determine the median or the second quartile Q2. Median is also called Q2. So if I just take the edge off, right, work my way towards the middle, kind of, I don't want to scratch them off. Okay, I'm just gonna underline them. Work your way towards the middle to find the median. Well, I got 2 numbers left. Okay, so the number exactly halfway in between them got to be the median. So the median got to be 78 plus 80 divided by 2, which we know is 79. So 79 is the median. Okay. So I want you to look at to the left side of the median. These 4 numbers together, okay, is the first half of the data. So Q1 is the first quartile is divided by the data into 2 halves again. Okay, so the first half, if I divide that by half again, okay, work my way towards the middle, that means the 72 got to be Q1. Okay, my second half of the original data, Q3 is where I divide that. Q3 is the median of the second half, right? Q1 is a median of the first half of the data. Q3 is a median of the second half of data. So if I work my way towards the middle, 88 got to be Q3. Okay, so that's how we actually find our quartiles. Median, Q1, Q3. List your data from small to large, find the median first. So then to the left of the median, which is the first half of the data, find the median of the first half. Q3 is the median of the second half of the data. Okay. Now let's continue. Outlier. An outlier is a value in a data set that is either extremely small or extremely large, okay, as compared to other data. Sometimes outlier can be, outlier can be an error, for the person that collect the data. It can be an error while collecting data, or it can just be, a extreme large or small value. Okay, it might not be an error. It can be an error. Okay, that's what the outlier is. Interquartile range. Okay, we need this interquartile range to help us check for outliers. Interquartile range, also called the IQR, is a range of the middle 50% of data. So if you think about it, the middle 50% of data got to be from Q3 to Q1. So the interquartile range, to find that number, we take Q3 minus Q1. Okay. So to check for outliers using quartiles, we got to determine the first and the third quartile of the data, compute the interquartile range by subtracting them, and then determine the fences. Okay, lower fence will be Q1 minus 1.5, 150%. 1.5 is like 150% of the interquartile range. Okay, so that create a fence. Let's see how far are you away, how far are you below. Okay, the low, how far is the lower fence going to be below from the interquartile range, or from Q1, basically. So Q1 is 72. So 88, 72, the difference is the interquartile range. So what lies in the middle? So the mean of your data set got to be somewhere within this interquartile range. Okay, got to be somewhere right here. So the outlier will be occurring 150%, okay, below Q1. Another outlier, okay, can be 150% more than what Q3 is. So that's what we use to determine the lower fence and upper fence. So if a number falls outside, if a data value falls outside the fences, then those are considered as an outlier. Okay, so is more than 100% on the test considered as an outlier? Well, I'm going to show you how to find the 5-number summary using our calculator, because the graphing calculator can, will actually give us the median, the Q1, the Q3, minimum and maximum. So the inner quartile, so we can calculate the inner quartile range. So I'm gonna do what we've been doing from the past couple topics. Go to stats, choose number 1, edit. On the L1, type in these numbers. Even 110. We got 10 numbers, right? You enter these numbers, go back to stats, go to calc, choose number 1 variable statistic. Same stat as how we find mean and the standard deviations. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I'm missing some numbers. Sorry. Let me know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Missing some numbers. I might just be typing. Okay. All right, stack calc number 1. Oh Lord, why am I keep on missing numbers? 78, 88, 95, 61, 72, 80, 91, 82, 77, 110. I missed a number. Sorry about that. There we go. All righty. All right. So once you get this answer, right, go down, press the down arrow key. That's your minimum. So 5-number summary, minimum, Q1, that's your Q1, median, Q3, and maximum. All right. So our Q1 is 72. Our Q3 is 91. So the inner quartile range, okay, gotta find number 2, compute the interquartile range, 91 minus 72, which is 19. Okay, so is 110 is over 100% an outlier on a test? Well, 110, right? So lower fence, upper fence. So 110 is gonna be, we're trying to see if 110 is gonna be to the outside the upper fence. So upper fence will be Q3 plus 1.5. Okay, so Q3, wherever Q3 is, right? 91, go 100%, 150% of the interquartile range times by 19. 91 plus 1.5 times 19. That's only 119.5. So 110 is sitting outside of it, or 110 is sitting within 119.5. So 110 is not an outlier. Okay. So what I was trying to do up here is trying to draw this thing called the box whisker plot or box plot. Box plot is another way for us to describe the entire distribution of the data. Okay, we can use median and the IQR, inner quartile range, to describe the central tendency. Okay, because when we talk about central tendency, what lies in the middle, right? Where is the mean at? The mean should be somewhere within the interquartile range. So with these number I already have on my calculator, okay, I'm gonna construct a box plot, okay, in the graphing calculator. Okay, so all we're gonna do is with the number already in it, click on stat plots, color coded. So press second y equal. Okay, very similar to when I show you how to draw the histogram. All right, I'm gonna choose number 1. Okay, I'm gonna turn it on. So it's blinking on the word on. So I'm gonna press enter. So the word on is blinking. Okay, there is, so the first one, this one right here, the type of graph it displayed. The first one is called the dot plot, line graph, histogram. Okay, so I got 2 types of box plots. Okay, one of them will show the outlier, the other one don't. So I know I don't have an outlier, so I'm just gonna choose this one right here. Okay, highlight that, press enter. Okay, my X list is under L1, but frequency, I did not have frequency, right? I did not have anything on the L2 for frequency. So frequency, all the number I keyed in is 1 at a time, excuse me. Press alpha and the number 1. Frequency 1 at a time. All the data value occur 1 at a time. All right. I'm gonna press graph. Doesn't quite graph it, right? So go to zoom, go up to zoom fit number 0. Didn't do it for me. I'm trying to remember because I don't lost the stat. Maybe it's Zoom stat. There you go. Zoom stat number 9. Sorry, not Zoom fit, Zoom stat. Here you go. Here's your box whisker plot or box plot. Right. So on the graphing calculator, okay, if you press trace, see the median is 80, right? Go to the right. That's Q1. That's minimum. Q3 and go to the right. That's your maximum. So this is how we construct a box plot. So this automatically scale for me. The x-axis automatically scale for me. Okay, so this is very accurate. So this box is basically your interquartile range. Go from Q1, right? Q1, median, Q3. So the mean got to be somewhere in the middle. Okay, so if you think about this, the normal distribution or the bell curve shape. Remember there was other types from the previous topic that we talked about, skew right, skew left. See the line here is longer. So that means this graph is a little bit skewed to the right, just a little bit, because the 110, the tails is on the right, because the 110, a little bit big, but not an outlier. Okay, a little bit bigger than compared to other data value, but still not an outlier. So if we go back to the graphing calculator real quick. Okay, I'm gonna just kind of do this again. I want to see the mean real quick. The mean is 82, right? In the 80, median was actually at 80. So 82 is about right here. So again, the mean will always be somewhere inside this interquartile range, will always be inside this box. Okay, so that's why box plot is another way to help us to describe our data value or data set or the word distribution. All right, let's take a look at homework real quick. So question number 1 and 2 are fun definitions. So question number 3, consider the following data value. Use the graphing calculator to calculate the 5 number summary. Okay, so once you got just 5 number summaries, then you can enter them into the computer. Okay, so make sure you label them. Okay, when you enter, make sure you say number 1 and give me the answer, and make sure you enter number 2, give me the answer. Make sure you don't put them all together under the same graphical equation. Make sure you type in one line the answer and insert, and then press enter to press enter and then start another graphical equation. If you put all the answer under one graphical equation, then a lot of times we will not see what you actually entered. Okay, so enter the 5 number summary for me here. That would be great. All right, so just real quick, talking this video, we talk about what the relative position is. Take a look at the idea of quartiles, medians, interquartiles, and how we can use a 5 number summary to help us construct the box plot, so we can see, we can see the central tendency. All right, thank you for watching.